Welcome to the Smarter Balanced Universal Design, Accessibility, Bias, and Sensitivity Considerations training module. This module examines the concepts of universal design and accessible assessment in detail, describes how these concepts are to be applied to guide the development and review of the items and tasks for the Smarter Balanced Assessment System, and how issues of bias and sensitivity can affect the quality of items and tasks. The quality of an item or performance task is dependent on whether it is able to elicit responses that provide accurate evidence about the knowledge, skills, and abilities that are the target of assessment. When factors other than the assessment target influence the evidence elicited from a student, there is a negative impact on the quality of the evidence of student learning. As demonstrated in this module, there are many factors that can affect the ability of an item or performance task to elicit accurate evidence about the knowledge, skill, or ability developed by each student. Collectively, these factors fall under the broad category of accessibility and include issues such as the extent to which the item or task contains content that is biased against some students. The item or task includes content that is sensitive to some students. An item is difficult to access for students with specific learning or sensory disabilities. And the item uses language that is unfamiliar or unnecessarily complex for students who are still developing proficiency in English. As an example, consider this mathematics item that is designed to elicit evidence about a student's ability to use arithmetic operations with whole numbers to solve problems. Now consider 3 students who all perform arithmetic equally well. The first student is a very strong reader and is a native English speaker who is familiar with American football. The second student is still developing familiarity with English, and although he is able to decode English text well, he is unfamiliar with many pastimes common in the United States. The third student is also a native English speaker, but has dyslexia and experiences difficulty decoding text. While the item elicits evidence from the first student that accurately reflects her ability to solve problems using arithmetic operations with whole numbers, the second student may struggle with this item only because he is unfamiliar with the game of football and does not know the number of points awarded for a touchdown, field goal, or an extra point. The third student has difficulty understanding what is being asked because of his challenge decoding text. The way in which this item is designed and presented to the second and third students makes it difficult for them to access the item's content. In turn, this item does not appropriately measure the assessment target for each student, which in this example is their ability to solve problems using whole number computation, rather than their ability to decode word problems about the sport of football. For this reason, this item raises accessibility issues. Discussed in greater detail later in this module, one remedy for this problem is to place the in a school-based context that is more likely to be familiar to all students. This module explores several topics that can affect the ability of items and tasks to accurately access assessment targets. These topics fall into 4 broad categories that include universal design, bias, sensitivity, and accessibility. Each of these topics is examined closely in this module. Through this examination, it is easy to see how these ideas build on each other and how their impact on the quality of an item or task can be minimized by following several key guidelines for developing accessible items and performance tasks. The concept of universal design was first introduced by Ron Mace, who was a pioneer in the field of architecture. The principal aim of universal design is to create products and environments that are usable by all people to the extent possible without specialized adaptations or alterations. In architecture, universal design focused largely on designing buildings and facilities that could be accessed and used by all people regardless of potential physical disabilities. Universal design was a reaction against unappealing alterations and additions such as access ramps that were tacked onto buildings as an afterthought. Universal design has led to the integration of ramps, curb cuts, and doors that open automatically into buildings and pedestrian areas. Over the years, the concept of universal design has been applied to many different products, including lever handles on doors, larger knobs and buttons on appliances, closed captioning for television programs, and slip-resistant surfaces. Inclusion of these features improves the usability of products for some people, yet does not negatively affect those who do not necessarily need them, and often improves a product's use for everyone. Over the past decade, the concept of universal design has also been applied to education, and a few important nuances have been noted. Specifically, when applied to an educational context, universal design is not intended to produce one approach or set of materials that works well for all students. Instead, universally designed educational materials recognize the different needs students may have and build flexibility and alternatives into learning materials. This flexibility allows the alternatives to be matched with each student's individual needs. When applied to assessment, this more modern concept of universal design means that items and performance tasks are developed in a way that allows them to be tailored to meet the specific access needs of each student. By doing so, they are better able to elicit accurate evidence about an assessment target. In assessment, there are many different ways in which an item or task can be designed to be accessible for a broad range of students, and flexibility tailored to meet specific access needs. As an example, rather than using situations that may be unfamiliar to some students, an item or task might use language and situations that are common to all students. The item might also be magnified for some students with visual impairments, read aloud for students with decoding challenges, or presented using a reading guide to help a student focus on a single line of text. To understand the many ways in which the concept of universal design can be applied to assessment, it is important to understand how items and tasks are designed to function. While many people think of a test item as simply a question that students are expected to answer, there are actually 5 important steps to how an item or task must function in order to provide evidence that supports claims about an assessment target. The first step focuses on presenting information that is designed to create a context in which the student must apply the assessment target. The information presented always includes a prompt that establishes the context and the problem on which the student will work. In addition, an item or task may present additional stimuli like a reading passage, graphics, a movie clip, or a sound file. For selected response items, answer options are also presented. During this first stage, the item communicates information to the student which the student must be able to access and understand in order for the item to function properly. The second step involves the student applying the knowledge, skill, or ability that is the target of assessment as he or she works on the problem posed by the prompt. This step is the heart of assessment and is where the student applies the knowledge, skill, and abilities that are the target of assessment. During this stage, student cognition occurs as the student interacts with the item content and works to solve the problem posed by the item. The third step requires the student to produce an observable product that reflects the outcome of his or her application of the knowledge, skill, or ability that is the target of assessment. Because a student's mind cannot be seen as he or she applies the assessment target, the students must produce an observable response. For a selected response item, the product produced by the student is simply the answer option he or she selects. For constructed response items, the observable product might take the form of text, a number, a mathematical equation, a graph, a picture, or other creations. The fourth step focuses on scoring the student's response. Here, a rubric, scoring guide, or answer key is used to help interpret the student's response and to assign that interpretation a score. Based on one or more item and task scores, the final step involves making a claim about the extent to which the student has achieved the assessment target. Typically, the higher the student's score, the stronger the claim will be about the student's mastery of the assessment target's content. Through these 5 steps, items allow an assessment to stimulate the knowledge, skill, or ability that is the target of assessment for each student, to obtain evidence about the extent to which the student is able to apply the knowledge, skill, or ability to solve problems presented to them, and ultimately allow claims to be made about the student's mastery of the targeted knowledge, skill, or ability. Given the way in which items and tasks are designed to function, There are four main barriers to how well an item or task is able to access the knowledge, skill, or ability that operate within each student and elicit evidence to support the claims about the knowledge, skill, or ability that is the target of assessment. First, if a student is unable to receive information presented by the item or task, or if that information is misinterpreted by the student, the item or task may not appropriately activate the knowledge, skill, or ability that is the target of assessment. As seen in the earlier example, a student's inability to decode text or lack of understanding of a context, such as football scores, can result in poor activation of the assessment target. A second challenge can occur when students have difficulty interacting with or manipulating content as they work on the item or task. As a few examples, a student with fine motor skill challenges may have difficulty using a mouse to manipulate content in an interactive item. Or a student who has a vision challenge may have difficulty comparing information presented in a table with information presented in a graph. A third challenge occurs when the response produced by a student does not reflect his or her thinking or actual understanding. As an example, students who have difficulty keyboarding may produce short responses for a mathematics item that do not include all the information they are thinking about. Similarly, students who are learning English may produce responses that contain both English and Spanish words, since the students may have difficulty fully expressing their understanding with the limited English vocabulary they currently have mastered. A final challenge occurs when there are errors in scoring student responses. Errors can occur for a variety of reasons, including misunderstanding what a student produces or having difficulty deciphering student responses. At each step of an item's functioning, one or more of these challenges can have a negative effect on the ability of an item or task to appropriately access the knowledge, skill, or ability that is the target of assessment and to elicit evidence that supports a claim about the student's development of that knowledge, skill, or ability. There is an important relationship between universal design and accessible assessments. One way to think about the connection is to visualize a tabletop. Just as the size of a tabletop limits the number of people who can sit at the table, the accessibility of an item limits the number of people for whom the item functions as designed. Principles of universal design are applied to the design of items and tasks in order to expand the number and variety of students for whom an item or task accurately measures the knowledge, skill, or ability that is the target of assessment. Using a context that is familiar with most or all students expands the range of students for whom an item appropriately activates the knowledge, skill, or ability that is the target of assessment. Similarly, using a larger font size to display content expands the range of students for whom the item functions appropriately by encompassing those students who have vision needs. In addition, avoiding unnecessary use of colors further increases the ability of the item to access the knowledge, skill, or ability that is the assessment target in students who have challenges differentiating colors. By considering many different possible challenges to the accessibility of an item or task, the number and variety of students for whom the item or task functions expands. A second aspect of universal design focuses on allowing accessibility extensions to an item or task to meet specific needs. As an example, for students who are blind and read Braille, it may be necessary to provide an accessibility extension to the item or task that presents information in Braille. Similarly, for students who have difficulty decoding text or who may be unfamiliar with the spelling or pronunciation of some words, another accessibility extension may present text-based information in a spoken or read-aloud form. For students who have recently begun to learn English, another extension might present the item or task in their native language. Additional extensions might include tactile representations of graphics and presentation of content in American Sign Language. Applying principles of universal design to item and task development has two important effects. First, the number and variety of people for whom the item or task functions appropriately in its original or default form can be expanded. Second, items and tasks can be designed to allow for the addition of extensions to meet specific needs of subgroups for whom the default form of the item or task is not appropriate. Together, These two approaches greatly improve students' ability to access the information presented by the item or task, and for the item and task to access the knowledge, skill, or ability that is the target of assessment for each student. One aspect of an item or task that affects its ability to accurately access the knowledge, skill, or ability that is the target of assessment is the extent to which information in the item creates bias for a specific subgroup of students. Bias occurs when an aspect of an item that is not specific to the knowledge, skill, or ability that is the target of assessment places a subgroup of students at a disadvantage or an inappropriate advantage. Some characteristics of an item that can create bias include context or examples that are unfamiliar to subgroups of students, such as sports, hobbies, or activities. The use of names of people or places that may be unfamiliar to or cause confusion for subgroups of students. For example, using Jakim, Sarasota, or Paris as a person's name in a word problem may be confusing to some students. Other examples include references to events or issues that may be unfamiliar to subgroups of students, such as a snow day, a state-specific holiday such as Bunker Hill Day, or a localized issue such as the development of a pipeline through a specific region. To reduce bias, a good practice is to refer to names, school-based activities, events, and issues that are likely to be familiar to students across the country. Sensitivity is another issue that can adversely affect the performance of some students. Like bias, sensitivity focuses on content that is unrelated to the assessment target itself, but is used to create a context in which the assessment target is measured. Sensitivity also focuses on content that may create unease in a student, may provoke negative feelings, or may appear to introduce beliefs or values that are counter to the student's own beliefs and values. Topics that may raise issues of sensitivity include religions, religious practices, and religious figures. Political topics such as party affiliations, abortion, school prayer, and the teaching of evolution, and issues of gender, race, and ethnicity, such as single-sex marriage, immigration, and cultural customs. Avoiding content that may raise issues of bias and sensitivity is an important part of universal design and helps to expand the number of students for whom an item or performance task is able to access the knowledge, skill, or ability that is the target of assessment. Specific guidelines that focus on issues of bias and sensitivity have been developed for the Smarter Balanced Assessment Program and should be familiar to all people involved in developing and reviewing items and performance tasks. As shown a few minutes ago, accessibility extensions are powerful tools that expand the variety of students for whom an item or performance task is able to access the knowledge, skill, or ability that is the target of assessment. Specific guidelines have been created to inform the development of several different types of accessibility extensions. While item writers and reviewers will not be responsible for applying the guidelines to develop accessibility extensions, it is important to be familiar with these guidelines and with the type of issues that challenge the development of accessibility extensions. All accessibility extensions are designed to provide information that supplements an item or task's content. The most common types of accessibility extensions include audio presentation of text-based content, audio descriptions of graphics, Braille presentation of text-based content, tactile presentation of graphics, presentation of text-based content in American Sign Language, and presentation of content in another language such as Spanish. To reduce challenges that may interfere with the development of accessibility extensions, the General Accessibility Guidelines describe many issues that should be considered when designing an item or task. As a few examples, graphics should only be used when necessary and should contain only the information needed for the problem at hand. Idioms, jargon, and other terminology that cannot be easily translated into other languages should be avoided. All graphics should be clearly labeled and text-based descriptions should be created that describe the contents of the graphic for students without vision. And tables should be designed to be as simple as possible given their use in the item. By adhering to the General Accessibility Guidelines, accessibility extensions will be of better quality. To help guide the item writing work, there are 4 important accessibility challenges educators should consider as they develop and review items and performance tasks. The first category focuses on vision. It is important to remember that the visual acuity of students who will be assessed using the Smarter Balanced assessments will range widely. To improve accessibility for students with vision needs, 3 useful guidelines are: minimize the use of graphics, simplify the complexity of graphics, and simplify the complexity of tables. For example, this item is designed to provide evidence about a student's ability to use mathematics to calculate the time across time zones. The item includes a map that displays multiple time zones. One question to consider is whether this same skill could be measured without the map. If so, then the item should be rewritten so that the map is not required. If the map is required, a second question is whether the map needs to contain all of the information presented. As an example, since the item focuses only on Miami and Los Angeles, does the map need to display the other cities too? These questions are important to consider because the map may need to be converted into a tactile representation, and this additional information will complicate that process. For some students, the amount of information presented in an item or task can create unintended challenges. These challenges result from difficulties the student may experience receiving, processing, assimilating, and interpreting large amounts of information. When the item or task is not measuring students' ability to process and interpret large amounts of information, then the amount of information presented by an item or task can interfere with its ability to access the knowledge, skill, or ability that is a target of assessment. A few guiding principles that can limit the influence of cognitive load include minimizing the amount of information contained in an item, simplifying the layout of an item, and avoiding items that spread information across multiple pages or screens. As an example, consider this item that is designed to measure a student's ability to calculate the area of an object. The item begins with 3 sentences that present a context in which someone wants to calculate the area of an object. The item then contains an image of the object along with the actual prompt. While the context presented by the item places the problem in a real-world situation, the amount of text and the complexity of the situation unnecessarily increases the cognitive load. As an alternative, this version of the item simplifies the context, decreases the amount of text, and simplifies the graphics, but still provides a measure of the same knowledge and skills that are the target of assessment. As discussed earlier, the vocabulary and sentence structure used in the prompt for an item or task can present challenges, particularly for students who are still developing English language proficiency. While it is important to purposefully vary text complexity in reading passages and other stimuli, the prompt and other components of the item should minimize language complexity so that all students understand what is being asked of them. 4 guidelines that are specific to language complexity include: simplify vocabulary when possible, simplify sentence structure, avoid unusual names, places, and terms, and place problems in familiar contexts such as school-based activities or settings. Earlier, there was an item that placed arithmetic in a setting that may not be familiar to many students, specifically a football game. As another example, consider this item that contains a long, complex sentence and uses a name for a person that might be confused for a city. To reduce language-related challenges, this item could be written like this. In this version, the long, complex sentence has been split into 2 sentences, and the language has been simplified. In addition, the name Paris has been replaced by a more familiar name, Maria, in order to eliminate confusion between the name of a person and the name of a city. Some students who will be assessed by the Smarter Balanced Assessment Program will have challenges with gross and fine motor skills. In some cases, students will be able to use a mouse, but may have difficulty making fine movements and precisely positioning the mouse. In other cases, students will use assistive communication devices to navigate through a test and to interact with an item or task. In many cases, the assistive communication devices will only allow students to navigate and make selections using a limited number of keys or buttons. To improve accessibility of items and performance tasks for these students, it is important to consider the interactions and manipulations that students must perform in order to produce a response and to limit the number of manipulations required when possible. Avoid precise manipulations, such as selecting a single point in a graph. And minimize the length of constructed responses. Clearly, some items will require precise manipulations or extended written responses. However, when possible, care should be taken to design items that minimize these issues unless required to access the assessment target. As an example, consider this item that asks students to drag the one response option that does not represent 1/3 into the trash can. Rather than requiring students to drag an object into a specified location, this item could be rewritten as a selected response item for which the student selects the one response option that does not represent 1/3. Doing so reduces the motor skills required to produce a response but does not alter the assessment target measured by the item. As mentioned earlier, the General Accessibility Guidelines provide a larger number of strategies to employ and issues to consider when designing and reviewing items and tasks. While item writers and reviewers should be familiar with all of the concepts explored in the General Accessibility Guidelines, here are a subset of the guidelines that should be kept in mind when writing and reviewing items and performance tasks. These include: simplify vocabulary and sentence structure. Place problems in familiar contexts with familiar items and names. Use graphics only when necessary. Simplify graphics and tables. Avoid the use of color and maximize contrast. Avoid content that spans multiple pages or that contains multiple elements. Use highly interactive manipulations only when necessary. And identify terms and visuals that should not be altered. By following these and the other strategies presented in the General Accessibility Guidelines, the items and performance tasks educators write and review will better access the knowledge, skills, and abilities that are the targets of assessment and support the claims that form the heart of the Smarter Balanced assessment system.